Let's have a look at compound interest in this video. Compound interest, the easiest way of doing it is to use a technique that we looked at in a previous video where you increase a certain quantity by a percentage value. Let's have a look at this question. We invest £400 for 3 years in a bank at 7% per annum, that means per year, compound interest. Compound interest, notice, not simple interest, compound interest. Find the final total in the bank. Okay, well there's 2 points here. You've got to understand what compound interest is. First of all, what you don't do is this. You don't work out what 7% of £400 is, work that out, so that's the interest you get for 1 year, and then treble that answer for 3 years and add it on. What you're doing there is working out something called simple interest. Okay, that's simple interest. And you might get a question on simple interest in the exam. You're much more likely to get, however, a compound interest question, which is actually more realistic in real life. This is what happens for compound interest. You get 7% of £400 for the first year. Now, whatever that figure is, at the end of the first year, it gets added on. So you get a bigger total in the bank for the second year. So for the second year, you actually get 7% of a bigger total. Work it out, and the answer you get is an even bigger total. So after 2 years, your money in the bank keeps increasing and increasing and increasing. So the third year, you get 7% of an even bigger total. So in fact, you're getting 3 separate, distinct calculations. One for year 1, one for year 2, one for year 3. Now we have gone through in our notes a way of working out the compound interest calculations by doing it as 3 separate year 1, year 2, year 3 calculations. And if you want to, you can do that. The problem with it is twofold. One, it's time consuming. So you have to do year 1, year 2, you have to do at least 3 calculations. And 2, of course, it becomes an impossibility if the question says, can you work out the money in the bank after 27 years? Because you simply have not got the time to do 27 year by year calculations. So I'm going to show you a very quick technique that we use to get to the answer with a calculator on paper 2. What you do to get the final total in the bank is you take your £400 that you started with and we multiply it. And you're going to say we want to increase it by 7%. So you're going to multiply by well, if you remember a previous video, you multiply by 1.07. That gives you a 7% increase. But that's just for the first year. Now, I could work that out and see at the end of first year how much money I've got. But I'm not going to. I'm going to leave it like that and say, right, imagine you've got that much money at the end of the first year. Then for the second year, we're going to increase that by another 7%. So you times it by another 1.07. For the second year. And you'd work that out and that'll tell you how much money you've got after the second year. And then you go into the third year and you increase that, all of that, by another 7%. So you've got to times it by another 1.07 for the 3 years. Now that's fair enough. If it's only 3 years, you can do that times that times that, that's not a problem. But if it was 27 years, or 30 years, or 99 years, are you seriously going to write times 1.07 times 1.07 times 1.07 99 times? I don't think so. That's not a practical way of doing the question. So what we do is we make use of some shorthand maths. We say this is best written as 400 times by, you take the 1.07 and realise that 1.07 times 1.07 times 1.07 is best written as 1.07 to the power 3. So if you had 1.07 as given a 7% increase and you were there for 27 years doing this, all you do is put 1.07 to the power 27. And so you make use of the power button and you don't have to write this 1.07 loads and loads and loads of times, which would be not very practical to do. So on a calculator, all I've got to do is work out 400 times 1.07 to the power 3. So you obviously need to know where your power button is. The power button on my calculator is that little sort of hat symbol. But on your calculator it might be Y with a little power X, or possibly it might be X with a little Y. On some calculators you get X with a little box like that. Whichever one it is for your calculator, you need to find that button. So I'm going to press 400 times 1.07 power 3, and we will get an answer of 490.017. So 017 means 02 to the nearest penny, and we're in pounds. So the final total in the bank is £490 2p. Obviously, if the question said not find the final total, find the interest gained, the compound interest itself, well, you started with 400, you end up with £490 2p, then the difference between the two is £90 and 2p, and that would be the compound interest gained over the 3 years. Okay, let's just do a couple of other questions like this very quickly. Now you've got the background. So let's just cut the writing out. Let's say I invested £175 for 5 years. Let's say the compound interest rate is 11% per annum. Compound interest, I'll use CI to stand for compound interest. And I'm going to say find the final total. Okay, so here we go. The final total will be equal to, you take the £175, you multiply it by, if it's 11%, you're going to have 11% increase by timesing by 1.11. If it's for 5 years, you just raise it to power 5, and you reach for your calculator and you press those buttons. So here we go. 175 times 1.11 power 5 gives you an answer of £294, and it will be 89 pence if you round it off to 2 decimals. And there's the final total in the bank. It does it for you straight away in one line, literally spending no more than 10 seconds on the calculation. If you were doing it year by year, year 1, year 2, year 3, year 4, year 5, it might take you 10 minutes to work the thing out. And of course there's more chance that you'd make a mistake because there's so many more calculations involved. Obviously, again, if you wanted to work out what the actual compound interest was, all you do is you take that figure and you subtract your starting figure, and the difference would be the amount of compound interest gained for that year. Okay, I'll do one more, and then you should be able to look through your notes and practice all the examples we're doing on notes, and hopefully you'll understand what you're doing. Okay, so number 3, very quickly then, get rid of all of this. Number 3, compound interest. Let's invest, I don't know, let's invest a very small amount of money. Let's say I invest £2.47 in a bank for just 2 years, and the interest rate is only 3.25% compound interest, CI compound interest. I'm making this as hard as I can. Find the final total. Okay. So obviously it's not going to be very much money, but let's see if we can get it to the nearest penny. So the final total will be, you take the £2.47, and if you want to do a 3.25% increase, well, 3.25 is 3.25%. If you're not sure, then you could have reached for a calculator and you could have said 1 share by 4, and you get the 0.25 on the end. So you got 3 plus a quarter, 3 plus the 0.25, 3.25%. So when you've got a 3.25% increase, it's 1.32. That'll give you a, sorry, if that's a 32% increase, that's a load of nonsense. So I don't want to confuse anybody. If you want a 3% increase, it would be 1.03. That's better. 1.03 gives you a 3% increase. 1.3, remember, is 30%. So 1.03 is 3%. So if you've got 3.25, well then you just carry the digits on, 325. So you write 1.0325. 0.3 is the 3, and then the 0.25% afterwards, 25. So that's a 3.25% increase. If you're doing it for 2 years, you just simply raise that to a power 2. So you reach for your calculator. There we go, let's do this very quickly. Okay, put the numbers in. and we will get an answer coming out of, and it's 2.633. So to the nearest penny, it's £2.63 in the bank. And obviously, if you were asked what is the compound interest gained over the 2 years, you just take the two things away, which of course is what, 16p. 16p gain in compound interest. And there you go. Very simple, very easy if you practice it a bit, and you're doing this on paper 2 for the calculator paper. Okay, end of this video.